Well, one of the things we want to know about all of our functions is how to do calculus on them. As I said the other day, that way we can use more functions when we're working out rates of change and all those sorts of practical problems. So how do we differentiate a log function? So if you've got the log of some function of x, it's interesting, it turns out the derivative is the derivative over the function, so whatever you're logging. So you differentiate what you're logging and you put it over that function itself. Now that's if it's a natural log. If it's not a natural log, and it's rare, but it could happen, basically the formula takes into account the change of base formula and turns it into a natural log. So you still get the derivative over the function, but it's divided by the natural log of the base. Because if you remember the change of base formula, you end up dividing by the log of the old base. So that's where it basically comes from. So it's still derivative on function, but as I say, you also divide by natural log of the base. So to differentiate something like this, log of 3x plus 5, you differentiate 3x plus 5 and get 3, very good, 3. And put it over the original function and there it is, 3 over 3x plus 5. Log of x cubed then would be 3x squared over x cubed, which can tidy up to be 3 over x. Of course, the other way you could have done that, you still get 3 over x. I could have used my log laws to bring the power out the front and said, oh well, that's 3 times log x. Differentiate log x, well, derivative over the power would be 1 over x. 3 times that, and again you get 3 over x. So whether to use the log laws first or not, up to you. The log of log x, so it's the derivative over the function. Well, the function is log x, so log x will go on the bottom of the fraction, but on the top will go the derivative. Well, the derivative of log x is 1 over x, so we get 1 over x over log x. Well, we don't normally write fractions on fractions, so we'll move that denominator down and we get 1 on x log x. The log of x plus 3, x plus 2. Again, you could choose whether you want to do the log laws first, then differentiate, or just go ahead and differentiate. So to start off with, let's just go ahead and differentiate. So the derivative, now I'm going to have to use a product rule. So write down the first diff the second plus write down the second diff the first. Over the original function, x plus 3, x plus 2. Tidying up the top, we get 2x plus 5 on x plus 3, x plus 2. If I'd use my log laws first, well the log, and when we're multiplying two functions together, we can turn that into an addition, and then differentiate each of these individually, so the derivative becomes a little bit easier to work out. Differentiate x plus 3, you get 1, so it's 1 over x plus 3. The second one becomes 1 over x plus 2, but the difference here is now you need to do some algebraic fraction work to come up with the final answer. So we get our common denominator, add them together, and of course we get the same answer. Does it matter? Probably doesn't matter which way you go. I guess part of it depends what you're going to do with it. If you're trying to find the slope of a tangent, say, 1 over x plus 3 plus 1 over x plus 2 is a perfectly fine answer, because you're just going to substitute into that and then you just add together the two fractions. It's good enough for an answer. Totally, again, your choice what you do. So similar with division, I could do this one first by just differentiating. So derivative on the function, but of course I've got to use a quotient rule here. Square the bottom, write down the bottom, diff the top, minus, write down the top, diff the bottom, and then all of that is over x plus 5, x plus 2. So tidying that up, the top of the fraction becomes minus 3 on x plus 2 squared. Then I've inverted and multiplied by the x plus 5 on x plus 2. X plus 2 cancels, and we get minus 3 on x plus 2, x plus 5. Or, if I use the log laws first, then division is subtraction. Derivative of log x plus 5 would be 1 on x plus 5. Derivative of x plus 2, 1 on x plus 2. So again, a bit of algebraic fraction work, and we get the same answer. possibly the second way is easier with that, because, you know, fraction on fraction, it's easy to make a silly mistake with that. But yet again, it's just personal preference, which way you want to go with that. Right, here's one where the base is not e, not the natural base, it's base 10. But what I said was we still do it exactly the same way. So derivative on function, 6 on 6x, but we also, on the bottom of the fraction, multiply by the log of the base. So log of 10. And in this case, the 6 will cancel with the 6, and we'll get 1 over x log 10. Now when you're writing down with the logs something like x log 10, it's better to put the pronumeral at the front, because if you put it second, very easy to mistake it and think you're saying log of 10x. So we usually put the x at the front for this one. Okay, 12b, 12c. You'll see there's a mixture of questions in there on just differentiating, but then of course all the applications we saw, curve sketching and things like that, using, now we've got log functions in there as well.